Hi everybody, today we're talking about functions. A function is a piece of code which is grouped together, and this group has been given a name, and by calling this name you are running a certain piece of code to solve a specific task. And we have some examples which we have already seen previously in the course, which is the length function, the type function, and the sum function. And of course, the name of the function, Control Enter to run that cell again. The name of the function actually tells us something about what kind of task this specific piece of code is accomplishing. For example, the len function calculates the length of some data object. And the type function gives us the type of the data object. And the sum function sums up several numbers in a given data structure. There are several reasons why we would like to join certain pieces of code together into functions. And one is to reduce the complexity in our program by sorting or organizing the code into specific parts or logical sections. And the second reason is that we make our code more reusable, because think of it, if you are calling the sum function several times, you could actually write the code which the sum function contains, but that would mean that you are copying code several times. So it makes your code more reusable to make a function and use that function by a function call. And another reason is that variables which are defined within the function, which means that they are only used within the function, they do not work outside the function, which means that you do not clutter the namespace with a lot of functions which have been temporarily made and you have not gotten rid of them. So we can start with the simplest function, which is a function which is doing nothing. Okay? It's not doing anything. But here we can learn how to make a function. So we are defining the function as this. You have to write def for define, and when you do that, Python knows that you are going to define a function and that all the code here within the function will be given this name. So the do_nothing is the function name. And you should give the function a name which is quite logical and tells you what the function code actually does. Like up here, the sum function, well, you kind of know what the sum function actually does. It's summing numbers. Whereas the do_nothing function is actually doing nothing, because within the parentheses we could pass in some arguments or some parameters, but we're not doing anything with this function, so we do not pass in any parameters. And the first line of code is ending with this colon. And whenever the colon comes, then Python knows that the body of the function is placed. So if anyone is calling the do nothing function, then we are just running pass, because a function cannot contain nothing. So if we run this, we get an error, but if we write pass, then you see here the number updated, so we have defined our function. But in order for us to actually use this function, we have to call it. And we call it by writing the function name and parentheses. So whenever you see these parentheses after a name, you know that this is a function call. So we are actually using a function now. So if we run this, well, this cell updated or ran, but nothing happened. It's because we defined the function body as pass. And we do that often if we are just writing these function definitions just to make sure that we have all the functions ready, and then later on we are going to write in the function body. And when we are calling the function, we are putting these parentheses, because if we did not put these parentheses, it's like we are calling a variable. So to make sure that we are calling a function, we have to have these parentheses. But the do nothing function did nothing. So it's kind of boring. So let's make a function that prints something. So we are defining our function as print something, and we do not need to pass in any numbers or text, and we end the line with a colon. And the function body in this case is a print function. So here we are actually calling another function within our function. Okay? So you can do that. So you can call a function within a function within a function, and so on. So in our case, our function body is running this line of code, the print statement. So we are going to print, this is printed to screen because I called the print something function. So if we run this, we see that we ran this cell. So now we have defined a function called print something. So if we call the print something function, then something is happening. When we are defining the print something function, nothing is happening. Python just knows that, well, if we call this print something function, then I should run this code. Now that we are calling the print something function, Python knows that it should print. So here you go. This is printed to screen because I called the print something function. But up here, we only have one line of code. you could have several lines of code in your function definition. So if we run this cell, then we are defining this print several lines function. And this print several lines function has several lines of code calling the print statement. And then to actually run this function, we have to print, or we have to call the print several lines function. So if we run this, then this code within the print several lines function actually runs. So one by one, these runs. This function has several lines of code. But these functions, they did not take in any parameters. So let's make a function which takes in a parameter, a piece of data to work with. For example, a number here in the print number function. So we are defining our function with a def command. We give the function a name, and here we are going to pass in a number. And what we are going to do with this number is just to print the number. So if we print a number, or if we call the function print number and give it a number to work with, then, well, we have to remember to define the function first, and then we can call it. So here we just put 3 into this temporary variable called number, and then we can use this temporary variable and what's in it in the function body. So now we are printing number, but number contains 3 because we passed in 3 into our function. So we are printing 3, which we see here. But you do not need to hard code the number here. You could actually pass this in as a variable. So let's store a number in a variable called myNumber, and then we could call the print number function and pass in myNumber. So if we run this, we should get 4 because we called the print number function, and we passed in whatever is in the myNumber variable, which is 4. So this contains number 4, but in the function definition, this number 4 is put into the temporary number variable. And the function uses this temporary variable to do something with our number. And up until now, the functions we have looked at, they have not given us anything else than some printed numbers to screen. But what if we would like to kind of have a piece of code which does some calculations, and then we get the results from that calculation. But first we can look at a function and how you return a number from the function. So here we define our function called return number. It does not take any parameters, but when we run this, or when we call this function, we are going to run 2 lines of code. We're going to set the number 2 in a variable, and we are going to return the variable. So if we run this to define our function return number, then we can use our return number function. And we are going to print whatever return number returns, which is 2. But if we update this to 33 and we print return number and what return number returns, then we get 33. And this variable, instead of just printing what the function returns, we can actually place this the value in this variable into a new variable. So for example, in our case, return number returns 33. We have seen that now with the print function. But we would like to call the return number and put this whatever return number returns into something called my variable. And then we would like to check what my variable actually contains. So if we run this code, we see that return number returns 33, and this 33 is put into my variable, and we are going to print my variable, or what's in my variable, which is 33. Up until now, we have just put into our function one number. But what if you have a list of numbers, and this is our program that we have written to calculate the average of a list of numbers without using our own user-defined function. So we have created this list of numbers called number list. We have summed up the numbers in the list and put the sum into a list sum variable. And we have calculated the length of the number list, which is the number of entries in our number list, and stored that number in our list length variable. And then we have calculated the mean, which is just the sum of the numbers in the list divided by the number of numbers in the list. So, and then we are printing the mean is, and we get the average. So if we run this, we see that the mean, or the average, of these numbers is 6.71. But if we need to do this several times, calculate the mean of a series of numbers, or a list of numbers, then we could actually write a function that takes the list as a parameter and calculates the mean of the list in the numbers. So we call this function average list, and we pass in one variable, which we call number list. And as we did up here, we kind of do the same, or we have the same commands here, or the same code here, but we're putting it into this function. So we have a sum of the numbers in the list. We have the number of entries in the list, and the sum divided by the number of entries gives us the mean. And in this case, we would like to return the mean from this function. So we have to define our function before we use it, and then we can use it as many times as we want. So here we define a list of numbers. We call it number list. And we call our average list and pass in our list of numbers stored in number list. And this function returns a number which is the mean from our calculations within the function body. So we could put this this mean in a variable of our choosing. So we can run this cell, and we see that the mean of these numbers is 6.71. This variable here can be called whatever we would like. We can call it m for short. It does not have to have the same name as the temporary variable within the function definition here. So if we run this again, we see that the number 6.71 was put into this mean variable within the function body, and we are returning the value in the mean temporary variable within the function body. But in our case, we're assigning that value to our variable called m. So, but now that we have defined our function, we can call our function again and again. So this is the main benefit of using functions. It's really time saving. So here we have another list of numbers, 1, 2, 3, 4, 5, 6, which is the sides of a die. And we store these in a number list. And we would like to know what is the average of the numbers when you are rolling a die, a 6-sided die. And the average outcome is 3.5. And down here we have another set of numbers, and of these numbers the average is 7. These lists of numbers have had 6 entries, or 6 elements, you can say. But these functions that we use within our function definition, they can handle lists with arbitrarily many entries. So in our case, we could, if I get the correct cell here, then we could pass in only 3 numbers, and we could get the average of 1, 2, and 3. We have seen several examples of value returning functions, which is this: when you have a return statement, you are returning a value which can be put into a variable. And the alternative to a value returning function is a non-value returning function. And a non-value returning function is a function which is not returning a number. It's doing something with either just a print statement, for example, or you could take an input, but you are not returning anything, but, for example, this print statement. So here we have a number list as our parameter, and we are defining our function, and it should just print the mean is and the mean. So here we can call it without assigning it to a variable. So for example, we have a number list, or a list of numbers, 1, 2, 3, stored in our number list variable. We are passing this list into our function call, and we have printed the mean is 2. But you can assign a non-value returning function to a variable. For example, we can call this function which just prints the mean is. It does not return anything. So what do we get if we run this code? Well, this prints this, but what has been stored in my mean variable? Well, we could print my mean, and it's 2. However, I made a mistake here, and I put this output here in my mean variable. Then I have to print my mean, and it actually returns none. So if this variable, or no, if this function does not return anything, then if you set a variable equal to the output from a non-value returning function, then the value in the variable will be none.